Good morning. Now I'm going to take seminar on finite element analysis and its basis. What is FEA? FEA is a numerical technique for finding approximate solutions to boundary value problems for partial differential equations. In simple terms, FEM is a method for driving up a very complicated problem into small elements that can be solved in relation to each other. Useful for problems with complicated geometries, loadings, material properties where analytical solutions cannot be obtained. How FEA works? FEA uses the complex system of points called nodes, which make a grid called a mesh. The mesh is programmed to contain material and structural properties which define how the structure will react to certain loading conditions. Nodes are assigned at a certain density throughout the material depending on the anticipated stress levels of a particular area. Regions which will receive large amount of stresses usually have a larger node density than those with experience little or no stresses. The mesh act like a spider web in that from each node. There extends a mesh element to each of the adjacent nodes. This web of vectors is material properties to the object creating many elements. Next, you will see types of FE analysis. First is structural analysis. Structural analysis consists of the linear, non-linear models. Linear models use simple parameters and assume that the material is not plastically deformed. Non-linear models consist of stressing the material post its elastical capabilities. The stress in the material then vary with the amount of deformation. The next regressional analysis, it is used to test a material against random variables, shock and impact. Each of these incidents may act on the natural vibrational frequency of a material, which in turn may cause resonance and subsequent failure. The next is a factic analysis. Factic analysis helps designers to predict the life of the material or structure by showing the effects of cycle loading on the specimen. Such analysis can show the area where crack propagation is most likely to occur. Failure due to fatigue may also change the damage tolerance of the material. The next finally is the heat transfer analysis. Heat transfer analysis models conductivity of thermal fluid dynamics of the material or structure. This may consist of a steady state or a transition transfer. Steady state transfer refers to the constant thermal properties in the material that yield linear heat diffusion. How FEM help design engineers? It is easily applied to the complex irregular shaped objects composed of several different materials and having complex boundary conditions. Applicable to the steady state, time dependent and eigenvalue problems. Applicable to linear and non-linear problems. One method can solve a wide variety of problems, includes solid mechanics, fluid mechanics, chemical reaction, electromagnetics, biomechanics, heat transfer, and acoustic, and etc. How FEM helps design organization, reduce testing and redesign cost through shortening the product development time, identifies issues in design before tooling is committed, redefine components before dependency to other components, prohibit changes, optimize performance before prototyping, discover design problems before litigation. In FEA, many steps were involved, which involves the first step a discretization, next selection of approximation of functions, formation of total stiffness matrix, formation of element loading matrix, formation of total loading matrix, formation of overall equilibrium equation, implementation of boundary conditions, calculation of unknown load displacements, finally the calculation of stress and strain. In FEA, the basis involved pre-processing. Here, a finite element geometry into subdomains for mathematical analysis, and the material properties are applied and also the boundary conditions. In this case, the governing matrix in solution. The next step is solution in governing phase. In this case, the governing matrix equations are derived and the solution for the primary quantities is generated. The final step is the post processing. In the last phase, checking of the validity of the solution generated, examination of values of primary quantities such as displacement and stresses, error involved in the carried out. The advantages of the FER can readily handle the complex geometry, can handle complex analysis types like vibration, heat transfer fluids, can handle complex loading, can handle complex restraints, can handle bodies comprised of non-homogeneous materials, specific material effects or handles such as temperature and dependent properties, plasticity, creep, swelling, etc. The finally is a disadvantages of FEA. A specific numerical result is obtained for a specific problem. The FEM is applied to the approximation of a mathematical model of a system. Experience and judgment of are needed in order to construct a good finite element model. A powerful computer and reliable FEM software are essential. Input and output data may be large and tedious to prepare and interpret. Numerous errors such as limitation of the number of the significant digits rounding occur very often. Fluid elements with boundaries at infinity can be computed and treated by using boundary element method. Currently, the software packages used for the FER, ANSYS, Nostron, Patron, NISA, LS Dynam, CATIA, ProE, SolidWorks, and Cosmos. Thank you.